This is ENME351, Lab 7 Stepper Motors by Garrett Schweitzer. Here we see the calculation to figure out how many steps we need for a full rotation. We have a gear reduction of 64. There's 4 poles, 2 phases. If we multiply everything together, we get 512. So there's 512 steps to a full rotation. Here's a review of the code that I have for my stepper motor. So start off, I made a few functions, rotate, and then a clockwise counterclockwise function I'll discuss in a minute. So rotate takes in the speed that we want, which is actually provided by a delay. Here I use 25 or 50 milliseconds. The current angle, and then the desired angle that we'd like the stepper motor to go to. So I have here what we're going to go through in the demonstration. I'll cover that in a minute. So we start off by the rotate function. We're basically calculating the delta here for the angle that we need to apply to reach whatever the desired angle is based on what we know is the current angle. And then depending on, of course, if that delta is positive or negative, this is a bit roundabout because I misunderstood the instructions at first, but I figured it out. So if the value is positive, we're going to go clockwise. We're going to pass the delay angle and what we desire to that. And then if it's negative, we're going to pass that to a counterclockwise function. We're going to return the angle plus the delta so that we can maintain the current position of the stepper motor. So then for clockwise, so what we're going to do here is calculate first the actual position, the number of steps that we need to go through to get to that angle that's desired. We're going to print that out, and then we're going to basically go through a for loop with this delay that we passed through earlier to enable and disable the coils to get that clockwise rotation. Then afterwards, we're going to disable both coils so that they aren't left energized, and then print out the angle that we've achieved. Counterclockwise is very similar. We're doing the exact same thing, except we're going now in reverse by utilizing the other coil, the other two coils, energize and de-energize those. So the way my code is set up, I can basically demonstrate all the requirements in one go. So we're going to start off by going from 0, which is the current position, to 360 degrees, so full rotation at the faster speed, then back to 180 degrees, then back to 90 degrees, and then back to 45 degrees at the slower speed, and then back to 0 degrees at that faster speed again. Now we'll begin the demonstration here. So we're starting by going to 360 degrees from the rest 0 degree position, full rotation at the faster speed. And you can see I have the end scope set up. That was for diagnostics, for me monitoring what all the output pins are doing. So then we're going to calculate the new delta, which is back 180 degrees to get to the 180 degree position at the same faster speed. Now we're going to go to 90 degrees, which is a negative 90 degree delta, and 45 at that slower speed, you can say. Then we're going to go back to 0 at that faster speed. And that's complete. So I've demonstrated forward, reverse, 2 different speeds, 45, 90, 180, and 360 degree rotations.